All right, so here is the formal definition for a set. A set is a collection of items that have no duplicate elements and have at most one null element, right? So adding apples to the set, apples, oranges, pineapples results in the same set, no change. So that's kind of a big thing here that I didn't go over in the last video, but that's why we have 2 videos on this, right? So now this actually gets to a question that a lot of students have asked at this point, which is why does the add method return a true or false, right? You're adding something to a array list, right? You're always going to be able to add something to an array list, so why does it return a Boolean? Why isn't it just a void method? Well, it's because it's mandated by the collections interface. And the collections interface is basically built in mind that maybe sometimes you can't add something because it already exists in your data structure. So set.add hello, right? So we're going to surround the first set.add hello with a print line statement, and that will return true. And the second print line statement will return false because you can't have duplicate items in a set. Big rule there, right? Big rule with mathematical sets too, right? True, we were able to add hello there. Second time around, we tried to add hello. We got false back, so we didn't add it, and sure enough, there's only 4 items still. So, and at most one null element, right? So we can add null. Let's go ahead and see that. Set dot add null. Right, and that kind of makes sense. There's already going to be a null in this, right? We won't be able to add another null because there will already be a null in the set. So we went over these operations. We went over testing for membership, the contains method, adding elements. So these are the elements that we typically do, the operation we typically do on sets. Testing to see if it has it. Adding an item. Removing an item, contains, add, remove. So then we have the union, intersection, difference, and subset. So I'm just going to quickly review them for anybody who's, for some reason, again, not done sets ever, or maybe you've just not done sets in a while and, you know, it's time to review them, right? The union operation, right, if we think of this as a Venn diagram, and we'll go back to the recordings over here, we think about this as a Venn diagram. Right? We'll have the circle set 1, set 2, right? Venn diagram, right? S1, S2, right? A union would give us both the items in S1 and S2, right? So S1 union S2 results in basically a new set that would contain all the items in this. And if there's any items that appear in both, right, we'd get them as well, just a single copy of each, okay? Whereas an intersection, right, would basically just give us this shaded area, okay? It would just give us S1 and S2 and only the things they share in common, right? Okay, the other one, so the final one is S1 minus S2, right, which would give us a new set that would have, which would be the same as S1, but all the things in this common area removed, okay? So it would give us just the things in S1 that aren't overlaid by S2. And finally, so those are the 3 things that will result in a new one. And then there's one more operation called the subset operation, which basically asks us, are all the items in S1 in S2? And we can say to this one, no, right? Right, but if we had a small set over here called S3, right, we'd be able to say S3 subset S1. And that would be and that would return true for us. All right, so let's see that over here back on the slides. So and we see that's same over here. The union of two sets, A and B, are the set whose elements both belong to A and B, who belong to both A and B. So 1, 3, 5, 7 unioned with 2, 3, 4, 5. So that's going to output all the elements in both of them, which are 1, 2, there's 2 copies of 3, so we get 1, 3, 4, 5, and 7. So we get 1, 2, 3, 4, 5, 7. If we do the intersection instead, that's only going to return the common items, which are 3 and 5, right? 3, 5, 3, 5. So intersection gives you back a new set that's 3 and 5. The difference of those two things would remove the common. The difference of A and B would remove the common elements. It would remove 3 and 5 from our output. So we'd get 1 and 7 in this case, right? Because we remove 3 because that's in common, and remove 5 because that's in common. And we kind of ignore 2 and 4 because whatever. And finally, subset. A is a subset of B if everything in A is also in B, right? 1, 3, 5, 7 is a subset of 1, 2, 3, 4, 5, 7. Okay. So in Java, we don't use those names. Instead, we use add all to do a union, right? The add all method, which you've probably found out by now. Retain all for intersection, and then remove all for difference. And then contains all does the subset. So those are just, so that's it. That's the only difference we have. Here's all the methods that we basically think are important. So if you want to pause here, you can. But otherwise, and then if you want some more examples, you can flip through the slides, but I'll go ahead and now move on to applications.